Analysis is the most advanced functionality available in our simulation systems for laparoscopy training. Right now, the LAPARO Analytic is the only trainer in the world capable of measuring instrument movement and giving precise feedback to the trainee. This functionality greatly improves the learning process because it gives the teacher and the student verifiable evidence on performance. When the user logs in, they'll have the option of selecting the training. These scripts are tailored for specific modules to measure and score specific skills. Each scenario has different target parameters. Sensors hidden in the trocars will track the exact physical position of the instruments during training. The collected data will then be used together with computer vision software to perform a detailed training analysis. Upon inserting instruments into the trocar, the trainee will see windows emerge on the sides of the live video image. These windows correspond to each instrument. When the camera sees the instrument inside the field of vision, L and R will materialize on the top of these windows. Throughout the simulated procedure, the trainee is able to see these dynamic graphs at a glance. Activity, acceleration, jolt, hand oscillation, and clamp speed are all important parameters to keep in mind while training. Measuring and displaying them encourages the best habits from the very beginning. The graphs will flash red whenever the parameter crosses an allowable threshold. If an instrument is inactive, on the other hand, a corresponding graph will also flash blue. Aided by computer vision capability, the system also measures the movements of the left and right instrument independently. What results is an account of the symmetry of use between the instruments during a procedure. Laparoscopic surgeons must build a habit of using both instruments evenly. In training scenarios where symmetry is not important, it is simply not shown. After completing training, a score breakdown screen will be shown. Here, the student can see his main score as well as various score components. After confronting the score, the user can enter the timeline analysis interface. Here, students can play the video back at different speeds and they can scrub along with the graphs showing the instrument behavior in detail. The timeline analysis vividly highlights points of interest where instrument behavior might need improvement. Both the trainee and the educator can later review the timeline analysis with ease. Results from the analysis can be easily exported in all sorts of file formats for research and education purposes. Configured in this way, the system delivers the best results for measuring, reviewing, and improving laparoscopic technique.